So today we're going to do three properties of logarithms. We are going to learn the change of base formula so we can put some of these in our calculator if we need to. Because your calculator only has log on there, which is base what? 10. Okay. We've seen many other different bases than 10, right? It also has natural log, which is base what? E. So you could do those two, but you can't do anything else as of this point. So I'm going to give you that change of base formula so we can actually get approximations for these things. I will tell you that on your test, you won't have a calculator, so you will just put it in as you would have put it in your calculator. Does that make sense? So you would finish out the problem by using the change of base formula. So you're going to use this change of base formula a lot as we proceed. You're going to use the properties of logarithms to evaluate and rewrite logarithmic expressions, and you're going to use the properties of logarithms to expand and condense. So the last 2 days when we've covered those properties of logarithms, that's the reason, okay, because you need to use them. I'll let it unfreeze the screen. No, it only went once. Okay, so most calculators don't have anything but log base 10 or natural log. So you need to know the change of base formula, and it's right here. If you have a newer calculator, my calculator will do base. I can do base anything I want, but I more than often use the change of base because it's so easy to do. So the base 10, you have log base a of x. You have log of x over log of a. What did I change the base from? It was a, right?
Yeah.
Now it's what? 10. So the of is in the numerator and the base is in the basement where it belongs. You can also take log base a of x and do the natural log of x over the natural log of a. They both work. Either one. Either one will yield the same answer. So you need to know that you are going to use it repeatedly. Again, on your assignment, they're going to want a decimal approximation. On your test, you're just going to set it up in that formula, reduce what you can, and walk away. Okay? Your formula's written down?
No.
Hopefully you did not write the black words. That would be a waste. Okay, your change of base formula, log of x over log of a. How do I know what goes in the denominator? The base. Can I use either one I want? Yes. Doesn't matter. Now, I think in your assignment it says use natural log, and then other ones will say use just log base, log base 10, the common log. Excuse me, I couldn't find the words. Or it could do both. It could say to do both on the first part of it. So whatever I change it to would equal, correct? The entire way through. Good? Okay, so it use the change of base formula. So common would be base what? 10. Okay, so I have log base 4 of 25 would be log of 25 over log of 4. Which is also equal to the natural log, which is base what?
ln 20.
Well, it's base what though?
Base e.
E. So the natural log of 25 over the natural log of 4.
So it doesn't matter which one.
No. I think on your assignment, the first couple say to use like both because that's all you're doing.
So since we can't use our calculators on a test, that's all we would have to read.
Mm-hmm. Yep. And if you have your calculator handy, you would get that and have approximately 2.3219. And that's the other thing is if I give you a calculator and you give me an answer, it's an approximate answer, right? So then I have to take off if you don't put approximately. So you're just better off just, there it is. Okay, you're gonna need a calculator when we get to this bottom line, so make sure you have it out. Okay, so you have log base 2 of 12, so change of base would be what?
Log 12 over log 2.
Now I want to talk about this real quick. Log is a function, correct? And if you put your parentheses around that, you may see even more that it's a function. I cannot divide 12 and 2 because order of operations tells me I have to perform the function before I can divide, correct? Now I could apply some rules that we're going to learn about to reduce it, maybe, but I cannot just divide the 12 and the 2 the way it is right now. Everyone clear? Now if I had log of 2 over log of 2, could I reduce that whole thing? Yeah. Okay, so natural log would be what?
ln 12 over natural log 2.
Okay. And you guys got calculators out now, so what is that?
Yeah.
3.5849. Do you guys agree?
How did you do that?
And try it, guys. If you did natural log, then do log. And prove it to yourself that they're going to be exactly the same.
So what's the difference between natural log and common?
Nothing. Well, the difference is one is base 10 and one is base 2, but in the formula they both yield the same result. Okay? But the difference between common and natural is one is base 10 and one is base E, and the E is that 2.71828. But in the formula, again, they yield the same answer. Yes?
So the book has been asking us to round to the nearest third decimal, but on here you're running to the nearest fourth decimal.
I just threw them out. Follow what the book says.
Okay.
My rule of thumb in here is always give me what I gave you, unless otherwise told. Okay? And again, I don't do significant digits. I don't use calculators much in here because I think it's important for you guys to know how to use your calculator to aid you, but you need to know how to do this stuff so we can apply it later on and actually use it. So on your own, log base 20 of 0.25.
You were to find like for both base 10 and base E.
If you want, they should be exactly the same.
Oh.
If you want to write it, I would do it like you did up top, and I would just go across like that.
Yeah.
Yeah, whatever the book says, that's what you should give. And you're doing that, I'm going to recalibrate.
Negative 4.382.
I got negative 4.6.
That's what I got. Are we rounding it?
I don't.
Negative.
Thank you, Scott. Yeah.
Let's go.
I got negative 0.468.
Oh,
Yeah,
Seven, but
do you round it?
Yes, did I round it? Yes. Because my 7 was followed by a 5. Okay. guys, it's one problem for 3 decimals. They're going to say tenths. They're going to say hundredths. They're going to say all different. Okay? Round it to whatever they say. It's not a huge deal. Just round right. The other thing is, though, if you're going to use this in some other part of a problem, you're not doing this. You're using this. Got me?
You're just leaving it. as
You're
that.
just leaving it like this. We do not work with approximations in formulas. We use exact. Because if I work this out at the beginning of my problem and then put it in another step, and work it out and put it into another step, and then work it out and put it in another step, I've increased my rounding error by 5 times. We have the capability in our calculator to put all that in at one time. We're going to put it all in at one time. Okay? So we're going to learn to manipulate equations really well. So whatever they say in the book, just do that. Okay, so the properties of logarithms. First of all, before I even start, the log, base A, and natural log, the rules are exactly the same. Got me? Just natural log is all base what? E. Okay, so we have the product property. Now, I'm going to relate this. I want you guys to stop and think for a second. Not just stop for a second. Don't write. I want you to think. Because if you're writing, you're not what?
Thinking.
You're not thinking. I want you to be engaged with me, and I will give you a minute to write it when I'm done, okay? So, logarithms are inverses of exponential functions, correct? Okay. So, product means I'm multiplying, yes? In exponents, what do I do when I multiply them? What do I do to the exponents? Add them. So what do you think in logarithms you're going to do?
You're
when
gonna
you-
add.
You're going to add them.
Crazy.
Okay, then we have quotient. Quotient, what do you do when you divide exponents? Subtract. So in log, what do you think we're going to do? Subtract. Okay, then I have a power. Well, power to a power in exponents, what do I do? Multiply. So what am I going to do here? I'm going to multiply. Okay? The power, we'll talk about it a little bit more detail than that. But, so I have the product property. So I have log base A of U times W. Or UV, sorry. UV equals log base A of U plus log base A of V. Exact same thing for natural log. If this is 3 things times each other, what are you going to add? 3 times. Okay? You're going to just keep breaking it down. This goes for more than just 2. Please put parentheses around your quotient. I don't know why they don't have it there. So the quotient property is log base A of U divided by V is log base A of U minus log base A of V. And the same exact rule applies for natural log.
What's that second one? The last one? Log.
This one?
No, the last one at the bottom.
This one?
Yeah, that.
Okay, I'll just talk about it real quick. The power property, okay, now we said when we have a power to a power, we multiply, correct? So here, the same thing. I have log base A of U to the n, okay? This exponent comes out front and we multiply it by. So it's log base A of U to the n is n times log base A of U. So again, it works the same exact way in natural log.
This one over the-
Now, this last statement you need to remember. We are going to expand and condense. I'm going to take something small and make it big, something big and make it small. We are going to use these rules both ways, okay? And write down here. When simplifying or expanding, simplifying and expanding mean exactly the same thing. Your directions will say simplify and your directions will say expand. They mean exactly the same thing. Clear? Okay. You are not done until all numbers are prime and there are no exponents left. You are not done till all numbers are prime and there are no exponents left. Do I have a rule that can break down numbers that are not prime? Yes. Do I have a rule that works with exponents? Yes. So you are not done until every number is prime and there are no exponents left. And also, if you want to put this, there's no properties remaining. Like log base 10 of 1 is what? Zero. Log base anything of 1 is what? 0. Okay, so there you are not done until all numbers are prime, there are no exponents, and you should put probably no rules left to do. Okay? Everything has to be exhausted.
I'm exhausted.
You are? You haven't even started.
Well, everything has to be.
So when I multiply, what do?
Add.
When I divide, I.
Subtract.
When I have a power, I multiply. It comes out front and I multiply. And I'm not done till all numbers are prime and
there
there
are no exponents left or
No rules
left.
no
to do.
rules left. So you got to do it all. And is there any difference between simplifying and expanding?
No.
Nope. None. There is a difference
That was a
between
bit much.
expanding and
I'm
condensing.
sorry, I'm tired.
A little.
Maddie, tell me when you're done. I think you're the last one. Maybe.
Gosh,
Sadie,
not
are
to
you good?
thunder out like that.
Connor's
I'm
still
with you.
going.
Connor's still going to? Okay.
So you're looking to get
Maddie's the only one I can see right now.
Connor's
I
trying.
woke up in
11.
She's slow. Mentally. I'm upstairs.
No judgment. Other people are too.
Yeah, I should be.
Okay, guys. Are you done, Connor?
Yes.
Okay. We don't need the comments. Okay, so it says use the properties of logarithms to rewrite and simplify the logarithm. So I'm not done until it's all prime, no exponents, and no rules, right? Alex? What do you need a calculator for?
I thought we were gonna have to use it.
No. Okay, so is 6 prime? No. What times what? 6.
3 and 2.
Okay, so I have log of 2 times 3, yes?
Yeah.
And what do I do when I multiply?
You add.
Add. So I have log of 2 plus log of 3.
Yeah.
Do you have any exponents? Or any of those a special rule? No. Okay. Now, if I was log base 2, would it be a special rule? Log base 2 of 2?
Yeah.
It'd be 1, wouldn't it?
Yeah.
So I'd have to use it. Okay.
So you just keep it like that?
Yep.
So how'd you do that?
Well, what's 6?
That's 2 times
2 times 3.
What, can it be 6
Because 6 isn't prime. You want prime
times?
numbers.
Oh, what are prime numbers?
The
Yeah,
only
it's
one in
like
itself
one.
can go on 2.
I forgot about that part.
Wait, what did you say?
I asked what prime numbers were. Yeah, what are they?
They're like only one in itself can go into the number.
Oh, 1 and 3. 1 and 2.
Yeah.
Okay, so natural log of 2 divided by 27.
2 minus 27.
Okay, so I have natural log of 2 minus the natural log of 27. Okay, we took care of the quotient. Are all numbers prime?
No.
No. Okay, so we need to do the prime factorization of 27. Might want to think of
3 and
powers.
9.
3 and 9, but
7
9
and 9.
is 3 and 3.
7 is
7 3 is 21. Just kidding.
It's 3.
Okay, 3 times
3
9 is
cubed.
27, but 9 is 3 times 3. So 27 is 3 what?
Cube.
Cube.
I quit.
You have me thinking that.
3 squared times 3, so technically I was getting that, I just wasn't.
Okay, so I have 3 cubed, yes? So now I have an exponent. Where does the exponent go?
Power property.
Power property.
It goes in the front.
In the,
It goes just in the front here. It doesn't go in the front of the whole thing.
You multiply.
Do you? Okay.
So I now have the natural log of 2 minus 3 natural log of 3.
oh, what? So good.
So are all my numbers prime?
Yeah.
Yeah.
No exponents?
No.
No rules left? No.
No,
Now, this number here does not have to be prime. What I'm talking about are the numbers that I'm taking the natural log of, okay? When I say all numbers prime, you can't use a natural log rule on a real number. It doesn't, you can't just throw it in there. Okay. So the natural log of 6 over e squared.
Natural log is 6 minus the natural log of e squared.
Okay, natural log of 6 minus the natural log of e squared.
Then you have to bring that exponent thingy to the front.
Okay, this exponent's going to go right here.
And we need to get 2 and 3 from the 6.
And you need to have 2 and 3 here. So I have the natural log of 2
plus the natural log of 3.
plus the natural log of 3.
Wait, why isn't it minus? Because it's.
No, we're just right here.
Oh, okay.
Minus 2 natural log e.
Would anybody else have done something different with the natural log e to the second? Because we're not done.
Did you just make it basic?
It's base e, right?
Yeah.
Natural log is base e. And so by rule 3, this is just what? 2.
2.
That's just 2 by rule 3. Now, we didn't do that. We did this. Okay? But what is this?
1.
1. So I have negative 2 times 1, which is just what?
Negative 2.
Negative 2.
Why would it be 1?
Because rule 2 says when the bases are equal, and it's basically rule 3, right? The bases are equal, it's the exponent is 1.
What base? What's the other base?
The base of natural log is what?
E.
E. The other base is e, with e and e.
Uh,
Okay? So that's what I mean by exhausting all the rules. We can't leave it. Why can't we leave it like this?
Because we're not done.
Because
all
we
the rules
still
and
have-
rules left.
One of our properties of logarithms, right?
Oh,
Okay, so prime numbers, no exponents, and all my properties need to be taken care of.
I'm ready for more.
No.
I'm ready for that.
Okay, now the last one said, it said simplify. Okay, so log base 2 of 432.
Ooh, why does that have to be a big number?
That's when you do.
Before we even start, we need to like break it down, right? We need to figure out what it's
Factors
prime
of
factorization.
432.
Okay, I know that 4 goes into 432. Does anybody else know that?
yes, because 4 and 32.
Because 4 goes into 32, right? And I'm starting with 4 just because it's bigger,
108.
right? Okay, so 4 goes in there, 108. Okay, well, does 4 go into 8? Yes, so 4 goes into 108, right?
Yes.
So 4, so 2 and 7? Yes?
Yeah.
Okay, well, we already know 27 is 3 cubed. Yeah? So I know this is 3 cubed. But what is my base? 2. So do you think I wanted to make my 4s into like base 2?
Yeah.
Because it would allow me to use other properties, wouldn't it?
I guess it's
So-
yes.
This is 16. 4 times 4 is 16, which is 2 to the 4. So I now have log base 2 of 2 to the 4th times 3 cubed. Yes?
See, I understood this stuff before we got to this.
Okay. just go slow. What do we have to deal with first?
Exponent, making prime numbers.
What do we have to deal with first?
We have to
Well, we did the prime
base
numbers.
The base is 2 and
Okay, but we can't do anything, these are together, we gotta do what?
separate
We have to separate them. How do we separate
You add
multiplication?
them.
We add them. So we have log base 2 of 2 to the 4th plus log base 2 of 3 cubed.
Then you put those in front of them.
Okay? But over here, let's not waste our step.
2 and 2.
Rule 2 tells me if the base is equal to the base of the exponent, it's
So it'd
just
be
the
2.
exponent. No, it would not be. It would be 4.
4.
So it'd be log to the 4th power.
No, it just would be what?
4.
4.
And that's because it's log 2 and then the.
It's because my base and my base of my exponent are the same.
So what rules are they?
That's rule 3. That was
Okay,
your rule
so
3.
those two like. I know you don't like this word, but they're like.
No, you don't can't. No. If I would go through, Connor, if I would go through the whole process of simplifying that, I would bring out my 4. Okay, here.
That's
This
what
is
my
what?
brain calls it.
No, watch.
Yeah.
So I've log base 2 of 2 to the 4th equals x. Got it?
Yes.
Okay, so it's in logarithmic. I should put it in exponential, yes? Yes.
Good.
So it'd be 2 to the x equals 2 to the 4th. So by the 1-to-1 property, x is what? 4. So the whole thing is what?
4.
4. They didn't cancel out. The math got it to 4. No.
That's how my brain looked at it.
Well, that's wrong. Okay. Now over here, what did we do here?
You put the exponent in front.
Put the exponent in front, and I just have log base 2 of 3. So is everything prime?
No.
No.
Well, yes. Everything that the log is on, is it prime? Yes. Are there any exponents in a log? No. And I've used all my rules.
Sure.
Yes. What?
You said whenever.
Okay.
Bad time.
There's a couple things we could do here. Remember when I had log of 12 over log of 2?
You can't divide.
And if you put parentheses, it helps you from stopping to reduce that as well. Okay, I can't divide that, right?
But you
No.
can divide this because it's in 1.
Right. This is all in one log, so I could divide it before I started, couldn't I?
Yeah.
Yeah.
And 3 goes into both of them.
3 goes into both?
Yep.
Okay, so
3
I have
over 100.
log of 3 over 100?
Yeah.
Okay, what base am I?
10.
10. Okay, just so you know. Okay, so division I,
3 minus 100. Log
okay,
3
log
minus
base. Yeah, not log base. Log of 3 minus log of 100. What base are we? 10. Okay. Am I done?
No.
Yeah.
Oh,
100
base
isn't a
10
prime
goes into
number.
100. I don't know.
What?
And your base.
100
isn't a prime number.
Right.
It
And
goes-
2,
it goes
10
into
squared. And 10 squared is 100, yes?
Yes.
So why did I keep reminding you what your base was?
Because it's 10 and it goes into it.
Right. So I have log of 3 minus log
Log 10
Thank you.
squared.
10 squared. So when I have my base, do I always want to see if that power can be used to simplify this more?
Yes.
Yes. Now by rule 3, this whole thing is what? 2.
Wait, what? Because I thought you had to put the 2 in front, so it'd be like log 3 minus 2 log 10.
But log of 10 is 1, and 1 times 2 is 2. If you use your rules, you don't have, there's 6 rules to use, yes?
Yeah, I don't really
get
So
that
if I wrote it out as log
What?
times 3 minus
If you did,
it'd be wrong.
if you did this, you would be wrong, because
No, I
what?
didn't do that.
Oh, yeah.
That's what I did.
Okay, what's wrong with what I did?
I had a log 3 in front of it.
It's not an exponent.
Well, yes, I just,
Oh.
You can't move it because
You got your log 10, so you can cancel out the.
okay, what is my, what is the base on that, on the common log? 10. If the 10 and 10 match, am I done?
Yeah.
No!
What does this equal?
No.
1. You have to use all your rules.
There's too many rules.
No, there's 6.
That's a lot.
And you spent 2 days learning 3 of them.
And I don't know a single
To be
one.
fair, I still haven't learned the
Okay.
first 3.
So you need to learn them.
I will, yeah.
Okay. Well,
Actually,
you
only,
just told me this was 2, so you learned one of them.
The third one and the fourth.
You just told me this was 2, so you learned one of them.
The last slide though was just.
Yeah.
We did the same
So you can
thing.
do that both ways and it'll still turn.
Oh.
Yeah, as long as you finish.
I gotta use the bathroom.
As long as you finish. One is going to be one more step further than the other. Okay. So, now it says expand. Expand is the same as simplifying, yes?
Yeah.
In all intents purposes. Okay, so first thing I would do is put log base 4 of parentheses 5x cubed. Why? The reason for that is then your brain knows they're all stuck together and I need to expand, so that means make it
Longer.
longer, right?
Yeah.
All of those things are what together?
Group.
They are grouped by what operation?
They are
Multiply.
Multiply.
together.
Okay, so they are all multiplied together.
Yeah.
So what am I going to do to all of them?
Divide them.
So
Add them.
them.
Where'd you get divide?
I don't know.
Okay,
This is all we're
so
gonna
when
do.
I multiply, I add, yes?
Yes.
Uh-huh.
Okay, so it's going to be log base 4 of 5 plus.
Log
Do
base.
you want to do anything with the 3 now, or do you want to wait?
log-
Wait.
Okay.
no way.
Log base
Wait
4
X
of x cubed plus log base 4 of
Y.
what? You have to put the 4s there every time. This does not work if the base of the logarithm are not the
Can you
same.
put the 3?
Did everyone hear me?
Yes.
Base is
If
the
the bases are not the same, I cannot combine them. Just like with exponents, I can't add exponents or whatever unless the bases are the same, right? Okay, so
Move the 3 out to the front.
the 3 has to go out front here. Is 5 prime?
No, yes.
Yes, so we're good, right?
Yes.
Yeah.
So log base 4 of 5 plus 3 log of
That's
base
fine.
4 of x plus log base 4 of,
That's
What?
fine too. So it's done.
so I'm done.
Oh, that was easy.
Guess what we do with condensing?
You put it down in
From
smaller
here
size.
To there.
So they'll give
No
you
way.
what we got.
They'll give you this, and you would put the 3 where?
In front, so it'd be
Back there, because it was an exponent. And all these are added, so they were all what? Multiplied.
Are we done? Like we leave it as that?
so we don't condense it.
No, well, you're going to have problems that say expand, and then you're going to have problems that say condense.
Okay.
Okay, so,
Let's do this one on our own.
Oh, never mind.
well, I think you could, but let me remind you, what is the exponent for square root?
Half.
2.
Half.
Oh.
So natural log
First was.
of 3x to the 1/2 over 7. Now try it.
I don't remember how to do that.
Try something.
I got it.
Get your head out of my way. So I could look at all. Yeah, that's why I
Oh,
moved over
silly,
there.
huh?
Well, it was good, and then all of a sudden it popped up.
Solid ground.
Right.
I know we did just like.
Oh, I got
I did this wrong, and I know I did.
this.
No questions.
Have you tried anything?
Yeah.
I don't even know where to start.
I got to a point where.
Yeah, can you get us started?
Well, what's division?
Add,
No.
Subtraction.
subtract, I just.
Would you put the half with both those things inside there?
Well, the 1/2 is gonna come out front, yes?
Yes.
Oh.
I didn't know if the 3x minus 5 stayed together.
Oh, okay. I forgot.
Okay.
Okay.
Now, do I have any rule that deals with subtraction or addition in a quantity?
Nope.
No.
No?
Word of.
So you don't have one, right?
Nope.
So you're done.
Yeah, I did it.
Oh, so
basically, I was gonna
try to solve the 3x.
Okay. So again, did I give you a rule that dealt with addition, subtraction?
Nope.
No. Okay, that's a quantity inside of there. Again, I cannot do anything with the quantity until I can perform the quantity, yes?
Mhm.
And I can't do 3x minus 5. So I can't do anything with it. Okay, condense.
Oh.
So we're gonna go backwards. Okay, the last thing that we would have done on the other is what we're gonna do now.
We're gonna put the half
Yeah,
in front of
put
the
the half.
x.
This was an exponent
Yes,
here,
okay.
I see that.
and the 3 was,
Wait, what did we
Next
just do?
exponent's there.
we expanded and simplified. Now we're condensing.
Yes.
So condensing is we take something big.
And make it small.
Let me talk through this one, okay?
Okay.
We take something big and we put it down. When we did these problems, how much, we got lots of logs, yes?
Yeah.
Okay, when we do these problems, we want to get down to 1 log,
Yeah.
okay?
I'm
So
sorry.
we just are putting it back. So the 1/2 came from an exponent, the 3 came from the exponent. So we have log of x to the 1/2 plus log of x plus 1 to the 3rd. Okay, then I have addition, and addition came from what?
Multiplication.
Multiplication. So I have log of x to the 1/2 times x plus 1 cubed. Now, what did x to the 1/2? What was 1/2?
Square root.
So I have log of the square root of x times x plus 1 cubed. Now, if this was just x plus 1, I would expect you to distribute, okay? But since it's cubed, I'm not going to make you multiply that out and then distribute, okay?
Is that all?
Yep, so we're done. So it basically goes the same way. If you don't have any properties left, you've combined everything, no rules left, you're done. You're just putting it back. You notice how many logs are there? How many logs are there? 1. Big thing with division, people like to leave at division the logs there, okay? If I do that, that's the change of base formula. That's not condensing it. So the whole purpose of this is to get it back to 1 log. Okay, so 2 natural log of x plus 2 minus natural log of x.
It was square root.
Division.
It's division, but that was a 2 right
Yeah.
there, right?
Yeah.
Now, you don't have to show that step if you don't want, but you know that's division, yes?
Yeah.
Okay, so it's going to be x plus 2 squared,
Times x.
not times,
Divided by it.
divided by x. Because it's it's minus. Okay, do you see how many logs are left?
1.
1.
It's actually.
One natural log. It is still a log function. Okay, now, I'm going to show you, but don't write it down. Do not write down what I'm showing you, okay? The mistake I will see a lot is this.
That's not right.
No.
That's the change of base formula, right? Okay, we didn't give you a problem like this and you go there, did we? Okay, this is not right. When we condense, we go down to one logarithmic function. Okay, do not. Usually that means that, and I can probably tell you that with 100% certainty. It's somebody who's barely done any homework, because they're like, these rules are easy, and they don't practice it, and so they make silly mistakes like that. Okay, so condense it again.
Okay, I'm running out of
Got another page.
I'm out of paper. Like, actually,
my notes are like 3 pages.
Okay. We've got a 3 there. Just a 3. Where'd that 3 come from?
It came from those thingies that have the exponents in the base.
Yeah, it came from like the bases were the same, right?
Yes.
There was an exponent.
It was an exponent,
Yes.
but what was an exponent on?
We don't
What's the
know.
base? Yes, we do. What's the base?
10.
What is the base?
10.
3.
So,
Oh,
E.
Ow.
W.
How do I know the base is
Single
E?
E in there.
It's a natural log.
It's a natural log. The base of natural log is E, yes?
Yeah.
So this 3 came from the natural log of E to the third,
Yes.
correct? And what does 2 come from?
10 times harder.
What?
What did
There
2
was
come
an
from?
exponent.
It came from exponent of ln e
Okay,
2.
so natural, well, no, not E, 4.
4 2.
Okay? And where'd the 9 come from?
Came from an exponent of natural log 2 to the 9th.
Why'd you put an E on the first one?
Because there's not.
Because the rule is, log, well, I can't. Log base A of A to the X is X. So we have the X, so it had to come from the base. How did I know the base was E? Because I'm dealing with what? Natural log. If it was log base 6, and there was just a 3 there, then it'd be log of base 6 of 6 to the third. Okay? You gotta remember where things came from. That's what you're asking yourself. Where did it come from? Okay, so left to right. What does that say? Plus multiplication. So this was the natural log of 7 times E cubed. Yes?
Yeah.
And then division. And then division, and then division. Now, here is a trick. That's a big 2. Here is kind of a helpful hint. When you have more than one division sign in a row, could I factor out a negative here
Yeah.
and then group this?
Yeah.
If I factored out a negative, that becomes what? Positive.
So then magically it's not division.
So it's still division of the whole
Just
quantity.
Divided that. with
Okay? So we're going to have this divided by this whole thing. We'll figure out what that whole thing is real quick. Minus. So I have 4 to the 2nd and 2 to the 9th. Well, that's silly to have it that way, but oh well. Because I want to make 4 2 squared, so that'd be 2 to the 4th, right?
that. Yeah.
So this would be the natural log. If this is 2 to the 4th and this is 2 to the 9th, it's 2 to the what?
11.
13?
That, 2.
Okay, so now I'm taking this divided by that, right?
Wait, how'd you get the 13?
She lost me all.
Okay, 4 squared,
It's 16.
right, but don't even think about that. If I have a 2 here, yes? So 4 is
2 plus 9 is 13.
2 squared, yes?
Yeah.
And then square it. So it'd be 2 to the what?
4.
4th. And this means multiply, so I add the exponents. So 4 plus 9 is 13. So I now have the natural log of 7e to the 3rd over 2 to the 13th. And you're good.
I
Okay?
knew that all along.
Yeah.
Is this my notes? My notes
Have a great day, guys.
are good. Oh, have a wonderful day.